things I want you to know. I have you looking at the integration as net change packet that you're going to be having as homework. We're going to bust through as much as possible today. But you guys all just told me that every single one with a year at the top had a hyphen and a 2, right? So this FRQ tends to show up second on the... Ooh. Do you guys remember how there are calculator FRQs and non-calculator FRQs? So guess where number 2 falls? In the calculator portion. Oh, grab calculators. Remember we were using them yesterday? Grab out calculators. We were using them yesterday. So in all of the long answer, for your purposes, you are using calculators. What does that mean? You don't have to be anti-deriving by hand, unless they're asking for a function. Remember, if they're not giving you a definite integral, or if you're not using a definite integral, maybe you'll have to be doing some anti-deriving, even on a calculator FRQ, to get like an f of t and not just an f of b. F of t being the equation and not just an f of b, a number. But besides that, you'll be using your calculator. That's one thing for you to realize. All of these long answers, you are to be using a calculator. However, another thing for you to realize is that even though these FRQs look very, 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 very different, as you read them, let's see if we can figure out anything that's the same. Ready? Set? Where's the first FRQ? Or the first long answer? It comes up pretty quick, right? Is it the one with the runners, A and B? Is that it, or is there one earlier? Oh, nope, there's some earlier. Keep going back. There's the amusement part. Keep going back. Temperature? Cool. Is that number 6? All right. I want you guys to take a second. You yourself and you guys hopefully know how to read, even though we don't do it a lot in math. I want you just to read the givens of every single FRQ, and in just a second I'm going to see if you were able to find any similar, any common threads. You don't have to read the whole FRQ unless you want to. I'm just thinking about the givens. Oh yeah. Everybody has this packet, right? Okay. Depends on how quickly you read, so just a little bit longer. If you have time and you've read all the givens, you can kind of start peeking at the A's, the B's, the C's. If all of these were number 2s and they have some sort of common threads. If it's not in the givens, maybe it's in the math. Okay, I want you guys to quickly brainstorm in your groups. So you've had time to kind of think about it, but you still might be like, I don't know if I see any similarities. Or what similarities do you see? It might not be amongst every single one, but maybe you see some similarities amongst one here, one there. Go ahead and, in your groups, talk it out for just a couple minutes before we brainstorm as a whole class. Go. If you guys haven't yet, if you were just talking about the givens, take one more minute and see if anybody looked at the how to solve. The A's, the B's, the C's, what were they actually asking for? Was there any similarity in that? If anybody did look at the actual solving to the FRQs, the A's, the B's, and the C's, any similarities in that? We'll do this again after the packet is due on Monday, but just thinking ahead, it's kind of helpful to see some of these. All right, I think we've pretty much thought through everything that we saw, yeah? Now let me ask you one more thing. Hopefully, one of the things that you guys said, one of the things that you guys said, and I heard some different words as you guys were talking, but hopefully one of the things that you guys said had something to do with anti-deriving or integrating. Hopefully. all of you saw in some way, shape, or form anti-deriving or integrating was necessary. I think integrating is probably the better way of saying that. Anti-deriving sounds more like plusy, indefinite integral, but I want you guys to take one more second, one more minute, and as a group, I want you to look at how the information was given to you. If there's an equation, what's the label of the equation? What did they give you? If it's a graph, what's the label of the graph? What did they give you? And I want you to think, how could you, how should you, how would you be able to integrate? Look at what they gave you. Did they give you a table? Did they give you an equation? Did they give you a graph? Did they give you all three? If you needed to integrate whatever they gave you, an equation, a table, or a graph, how would you do it? Ready, set, go. Go one by one, starting with the first one. How did they give you the information for the temperature one? How would you integrate? How could you integrate? Is it geometric? Is it not? Is there an equation? Is there not? How could you integrate? You don't have to actually do it. You don't have to actually try to plug it in your calculator, but could you integrate? How would you integrate? Okay. All right, kiddos. I realized in my notes I don't have them quite in order, so let's go ahead and see what you guys saw as we were going through. Okay, so number 6, this is the temperature one. Is that the first one? What did they give you? An equation for F being what? Careful, a letter doesn't mean anything, right? We need to think of what's behind the letter. Temperature. So this measures, plug in a time, and you get a degree, right? A degree in Fahrenheit. So this is a temperature equation. So if we did need to take an integral, what could you do? Yeah, just plug it into a calculator. No big deal. Make sure you're in what mode? Radian mode. Oh, that's all of calculus, isn't it? Okay. The givens was kind of lame. It was like, okay, temperature. Dun, 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 dun. Question, is temperature a rate of something? No, because the units are what? Just degrees Fahrenheit. So how could I get a rate of change of temperature from this? Take a derivative. Okay. I would need to take a derivative to get Fahrenheit per hour. How about number 7? What's going on? I'm giving 2 equations. They're kind of nasty. Good thing we can use our calculator. But what else did you guys see? They're both derivatives. Did you guys look and see who is E? There's no prime, but pause. What's the wording say? Rate. So is this a rate already? Yeah, plug in a T and you get, did you guys see the units, people per hour? That'd be a great thing to underline. People per hour. E stands for people coming in, adding to the number of people in the park. L stands for people leaving, taking away from the number of the people in the park. T is measured in hours after midnight. So what's this whole at 9, there are no people in the park? That doesn't make any sense. Wait, what does T equal 9 mean? What time is it? 9 a.m. When's the park open? Probably 9 a.m., which means at 9 a.m. they start letting people in. So we're not talking about the workers, we're talking about the actual people in the park. With no, I don't know, early entrance. Doesn't Disneyland have like an early entrance for, like, I don't know, moms and kids in the playground, something, something, something. Anyway, if you had to integrate, how could you? Oh, it's easy. They're equations. What can we do with equations every time? Plug it into our calculator. No big deal. But wait, if you integrate the rate of people entering, people per hour, what are you going to get? A change in? What are the units going to be if you integrate people per hour? Change in people entering. And then if we integrate this one, people per hour, if we integrate, we'll get the change in people that have left. Oh, and then there's a whole, did you guys see there was a whole other equation way down here? Interesting. And H is an integral of E minus L. Ooh. Number 8, what'd they give you? A graph of who? Velocity is a rate of change of what? So this one, they gave you 2 different rates, adding and subtracting. This one, they're giving you 1 rate. Well, 1 graphical rate, but did you guys realize there was a hidden second rate in the problem? Because you had 2 different runners, true? So runner A, you have the velocity graph up here. Runner B, you have the velocity equation down here. If you needed to integrate, if you're integrating velocity, what are you getting back to? Change in position, either displacement or total distance traveled if it's absolute value. If you needed to integrate an equation, you would just throw it in. But how could I integrate a graph? They didn't give me an equation for this. How do you integrate a graph? You don't. But how is a definite integral seen in a graph? Is it a slope? Is it a y value? Or is it an area? If I needed to integrate, if I needed to antiderive, if I needed to go back to change in position of this runner, I would have to do area. Area, could we do it? Yes. Why? Geometric shapes. This guy, what do we have? An equation of what? Okay, so we're given a rate. And then what else are we given? Yeah, we're given a clue as to the initial, right? If we needed to integrate, we could just throw that in. Sketch a graph. Do they actually want us to like put this in our graphing calculator and sketch it? Interesting. This guy, what'd they give you? They gave you a graph and what? Why didn't they just give us a graph? Because it's non-geometric. How would I be able to actually exactly find the area? I wouldn't. So, good thing they give me an equation. But why are they showing me the graph? Do you guys see that? Wait, this is a graph of velocity, right? Of rate? Why did they show me this? Well, whenever the rate is positive, aka whenever the values of the velocity are above, this whole area is how much this particle, this car, this something or other moves to the right. Now hold on, what's actually going on? Is this a moving right, moving left? No, this is cars turning left at a rate of cars per hour. Oh, how many cars? Okay, so it's adding how many cars, and then the rate of change of the cars turning left randomly is 0, and then more cars once again. To go from cars per hour back to cars, we would need an integral. Did you guys see they random? Oh, they didn't. I thought they did. Okay, sorry. I thought they threw in an equation later on, but they didn't. What's weird about this one? Table. What is table? L of t is the number of people. Is this a rate? No, it's not people per hour. It's just people. How are we going to get rates if they didn't give us rates? How do we take derivatives if we don't have equations, guys? Do you see the big word in letter A? Estimate. So if they want us to figure out what's going on at t equals 5.5, which is awkwardly here, we have people, we need people per hour. We need to somehow divide change in people over change in hours. Oh, do you guys remember we can estimate the slope of the tangent line by taking the slope of a secant line? Or estimate an instantaneous rate by finding an average rate? Is an average rate of change L of B minus L of A all over B minus A? I could find a little baby slope on the information right around that. They don't give me a rate, but I could estimate. What's going on here? So if I need a rate, what am I going to do? Estimate. Why? Well, they gave me a table, nothing else to do. What's going on? Oh, that's the last one. Hey, look, there's a random hidden equation. I bet we could do something with that. Biscuits and tea. Oh my goodness. I think I told you guys about this one quite a few times this year. Anyway, do you guys realize that when I yesterday talked about integration as net change, I said I was trying to protect you a little bit, right? And that we would start with motion, because motion, we know position, velocity, acceleration. You take a derivative from position to velocity, velocity to acceleration. You integrate from acceleration to velocity, integrate from velocity to position. But is that all that's on forever card number 42 is motion? Well, motion, technically everything's in motion, but the motion that we're used to with position, velocity, acceleration, no. What's the second one? And actually the most important one, and actually the most important one for anything AP-ish. It says, I don't care whether it's position or not. I just care about an amount. What is a quantity? Are we measuring people? Are we measuring degrees Celsius? Are we measuring, what else did you guys see in the different units of what was going on? Cars, right? Cars turning left. Are we measuring cars? Are we measuring, oh, actual movement of the runners? Okay, that could actually be distance. That would be like position. What else was in there? People in the amusement park. Which one? Temperature. Yeah. Degrees Fahrenheit. All of those things, guys, go in this category of amount of people. Amount of, well, okay, temperature is the amount of degrees. I don't know, that's awkward. But that's okay, it still works. Amount of, oh, there's the temperature of the biscuits, too, not just the temperature outside. The amount of, all of those were original functions. They might be asking us to find rates, or they might be giving us the rates, people per hour, cars per hour. I don't remember what else was per, but they might be giving us a rate, velocity, and going backwards. Or they might be giving us original quantities and we go forwards. There are a lot of comparisons, but there also are a lot of contrasts because these are very different types of problems, but the math is quite similar. Kiddos, let's go ahead and bust out as many of these long answers as possible. Long answers, but they're hard. Okay, hold on. Let's do some multiple choice first. Number one. Let's do some multiple choice first. Number one. The graph at right, I'm not going to do all of them. Some of you already started peeking at them last night. But the graph at the right shows the rate. Either we're given a rate, how fast a quantity is changing with respect to some sort of per hour, per year, per second. Either we're given a rate or we're given an original. It's always going to be one of those two. Sometimes they could give us acceleration, but it's rare, very rare. So this one, they're given a rate. All right, it's a per, gallons per hour. Which water is pumped from the storage tank? Approximate the total gallons. How do we go from gallons per hour to gallons? Integrate. But we don't have a function. That's okay. What did we just talk about? If we don't have a function, what do we need to think about? Area. Unless we're given a table, then we might have to think about Riemann sums. Oh, you just did test corrections and you did a right Riemann sum. That's a table. Anyway, coming back. We have a graph. Area. Oh, but it's not geometric. It's okay, because what did they say? Approximate. How can we approximate? I don't know. Does anybody see that this little square right here is going to have an area of 300? How'd I do that? 6 times 50. Yep. He has an area of 300. How many 300s do we have? 1, 2, 3, 4, 5, 6. Almost. 7, 8. All right, now we have to start having fun, yeah? 9-ish. We'll say that that's kind of with the 9 and with the others that are... 10-ish? Yeah? Maybe 11-ish when you put those in. Where does that send us? 11-ish times 300. That's 3,300. Oh, it's not even up here. What's the closest one? Yep. Number 2. Sorry, just kidding. Number 3. Don't want to do them all for you. The rate. Hey, they gave us a rate again. And an equation. Yay, calculator. Open it up, radio mode. At which customers arrive at a counter to be served. Guess what? FRQ 2 years ago. Customers arrive at a banana display. It was a thing. Is modeled by the function f of t. Circle the word rate if you have not yet already, and then be like, hey, you're important. Where f is measured in customers per minute. T is measured in minutes to the nearest whole number. How many customers? How do I go from customers per minute to customers? Ooh, no, not derive. How do I go from a rate back? Customers per minute back to customers. I integrate. I thought you said derive. Maybe you said integrate. Wait, how many customers arrive at the counter over? Is it asking how many customers are at the counter? And like you have some coming and some leaving and like it's this whole at thing, or is it an over? Oh. So a 60-minute period, isn't that going to be from 0 to 60? Aren't you going to plug in your f of t dt? There's no need to write more work. You're going to be wasting your time. Just get to your calculator. It's a multiple choice. They don't see your work anyway. Now, for my purposes, it's nice to sometimes see at least a little bit of what you were thinking so that when we go to grade, you can be like, what was I doing on this problem? I don't remember. So that's kind of nice as far as like if you take the mock AP, when you take the mock AP. Oh, we need to talk about that. When you take the mock AP for our final exam for the year. Or when we do lots more AP practice when it comes close, write down a little something just so you remember what you did. But you should be plugging and chugging it into your calculator. Who's already gotten me a number? You guys agree? Anybody? I see some head nods. Sweet. Number 5, a developing country consumes oil at a rate. Now it's oil? Sure, why not? I don't care. At a rate. What's nice? They give you... Hey, I know, it's the one that you've seen like 3 times now. Yeah, you should totally know it's D. Why should you know it's D? Yes, you've seen it a lot, but also it's barrels per year and you're going back to what? The amount, wait, they don't say barrels, little stinkers. That's okay, you need to know whatever. The amount of oil, are they asking for a how fast or are they asking for a how much? How much? So take an integral of the rate they already gave you, and they gave you the time 0 to 10. Although it would have been a whole lot nicer saying something about over those years or over those 10 years or anyway, but they gave you like a very mathy expression. All right, now let's go to number 7, the amusement park. You guys have already read the information, started to think about it. We were doing the odds, or we're trying to get as many odds done as possible so that this weekend you guys can do the evens. I might not totally solve, but I am going to help you start. Does that make sense? Then you guys just finish. How many people have entered? Wait, we already talked about these being rates. Rate entering, rate leaving, people per hour. How many people have entered the park by 5 p.m.? Well, when did they start entering? 9. And when are they stopping entering? 17. Don't we just have to go ahead and... Wait, this is long answer. We better show our work. You just did. Stop. Go to your calculator. Throw it in. Get an answer. Now hold on. Wait a minute. Hold on. Let's just strategize really quickly. Do you think you might have to use this equation at any other point during this problem? Possibly. So could you, on your home screen, could you type in 9 to 17 of, all right, put in the whole fraction, dun, 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 enter? Yes. But if you have to use this equation again later, couldn't you go to y1, y equals? And couldn't you put this expression in y1? And couldn't you put this expression in y2? And couldn't you just take the integral from 9 to 17 of y1 using your y-vars? And then you can keep on going and referencing y1 over and over and over and not have to retype this expression and type it in wrong. Anyway, long story short, round your answer to the nearest whole number. Why? Poor little people. Let's make them whole and not partial, yeah? Okay, letter B, the price of admission to the park. Oh, they bring in a new piece of information, whatever. The price of admission to the park is $15 until 5 p.m. After 5 p.m., the price of admission to the park is $11. How many dollars are collected from admissions? Guys, didn't we just figure out how many people have entered up until 5? What were all those people paying? 15. So can't we do $15 times the integral from 9 to 17 of e of t dt? But then there's a discount. Must not be Disneyland. Then what? Price of admission to the park is $11. But how do I get my people for $11? After 5, which means we're starting at what time? 17 hours since midnight. If you know Army time, it might be helpful. Wait, when do we stop? We need to stop when the park closes at 23. Yeah? What's going on in letter C? Let H equal. Who's H? The integral. Wait, we've been doing the integral. We've been doing the integral from 9 to t of e of, well, okay, whatever, e of t dt. And weren't we finding how many people were entering the park since the beginning of the day? What happens if we're subtracting L of x in the exact same expression? We're not just figuring out how many people entered the park, but also how many people left the park. Oh, guys, if we put this all together, how many people enter minus how many people left, what are we actually finding? How many people are in? Yeah. So right away, it might be helpful for us to be like, oh, hey, h of t finds the number of people in the park at any given time t. Oh, okay. So when it says something about h of 17 is, that's interesting. They're telling me how many people are in the park at 5 p.m. Because didn't they just talk about 17 a lot? Find the value of h prime of 17. Explain the meaning of h of 17 and h prime of 17. Oh, hey, we basically already know the meaning of h of 17. We just talked about how h is the number of people in the park at any given time. So h of 17 equaling 3725 people in the park at 5 p.m., right? I mean, you could write a little story about it, but whatever. That's how many people are in the park at 5 p.m. So what's going on at h prime of 17? Hold on. First of all, how do we find a derivative of something? We derive it. How do we derive h? We take the derivative of who h equals, of course. So how do we take the derivative of the integral? Is this a fundamental theorem of calculus part 2? And if h is the number of people in the park, isn't h prime the rate at which the people in the park are changing? If it's positive, then the people in the park are increasing at that time. If it's negative, the people in the park are decreasing at that time. Letter D. When are the people in the park? A maximum. A maximum people in the park. Oh, h is people in the park. Got it. So we want a max of h for t within 9 to 23. Hey, is this something to do with an absolute max? Testing the critical numbers and endpoints? Is that a thing in calculus? Yeah, it is. What else do we have? How about number 9? How about number 9? A particle moves along the x-axis, that's velocity via any time t. For t within 0 to 16 is given by, oh, this is a nice one. We have an equation again. And it's velocity, and we have a time interval. And they tell us a clue. They say the particle, the position at 0 is 0. Hey guys, if they say something about moving to the left, don't we have to figure out when velocity is negative? How do we figure out the signs of velocity? Yeah. Can't we do a sign chart to figure out the behavior of an original by looking at the signs of the derivative? Interesting. I bet the graph will help me. the graph's going to show sometimes velocity being positive and sometimes velocity being negative. Interesting. If they ever say give a reason, a sign chart doesn't count. You have to put what you see in words. Find the total distance traveled. Oh my goodness, isn't that just a formula? What's really cool if they give you equations and it's a calculator problem? Is there any more work to show? Absolutely none. Go get me a decimal. But don't forget if there are units, because units always count for points or they can take away. Oh, do they give me any units? Well, not much I can do, so we don't have to worry about it. Is there any time at which the particle returns to the origin? Do you remember yesterday that problem we were doing, how I said something started off, let's call this 0 at 2? And I could look at the area on the graph and I could see, oh, it moved right for a little bit, but then it moved left for a lot more, and I know that it passed the origin. And then it moved right a little bit. Something great to think about for letter D. Number 11. Question, how many odds are there? We're at number 11. How many odds are there? Is that the last one? Okay, guess what I want you to do this weekend? Finish up the odds of the free response and the evens of the multiple choice. Sound good? So what are you allowed to skip this weekend? The evens of the multiple choice. There's nothing to post in Google Classroom. I'll make an announcement just to remind you, but on Monday I need for you, your packet here, you have actually worked out all the odds with the hints that we have given, answered it to the best of your ability, and tried the evens on the multiple choice, okay? What's going on here? The number of people. Oh, estimate the rate. Didn't we talk about this guy? Estimate the rate. L prime is estimated by my last hint for the day. L of 7 minus L of 4 all over 7 minus 4. You actually have to plug in from the table. But what would your units be for rate if the original quantity is people and time is measured in hours? People per hour. Trapezoidal sum. Riemann approximations. Have your notes, have your worksheet, see what you can do on the odds and the evens multiple choice. I have homework spirals, but I think it's all period 6. If they're yours, come grab it. Hey guys. Bye you. Thanks for the Jeans Day money.